This trig ratio is a very important subtopic we need to discuss, and this is because sometimes we don't have calculator to calculate cos 220, cos 250. All we have is four figure table, and most time, in fact, some examination will tell you not to bring calculator to examination, or all you need to use is your four figure table. Most of them would allow four figure table and will tell you to do away with your calculator. So because of that, this topic is very important. How do you trash cos 220? How do you understand sine 320? And fortunately or unfortunately for you, sine 320 is not in your four figure table. You cannot check 320. As a matter of fact, it started from 0. Check your four figure table. It started from 0 to 89. It started from 0 to 89. So when you have cos or tan 120, 135, how do you do them? How do you work around those things? That is what trigonometry ratio is going to teach you. So if you don't have a calculator, of course, if you press calculator, tan 320 will give you a value direct, which is obviously going to be negative value. But how do we know? How do we do this without calculator? We were talking about the first quadrant, the second quadrant, the third and the fourth quadrant. We are definitely going to be using those quadrants. Let's begin from the first quadrant now. From the first quadrant. So I might have to draw a picture. So I need you to understand this picture. This is my x-axis and it is positive. Don't forget my x-axis as well on the negative side. You need that. My y on the positive and my y on the negative. And I told you first quadrant is from 0 that is less than theta, that is less than 90 degrees. So it is more than 0 degree and it's not up to 90 degrees. So we are talking about angle 30, 32, 45, 73, 71. That means it falls around here, anywhere here. So if I just have this line, just this line, that means anywhere, and this is my theta. It can be anywhere there. And if you have this one, you know definitely this is my y and this is my x. So I can call this one a z, like a 3D, you know. So we have this. So if you can have this one, this is positive, this my x is on the positive side, my y is also on the positive side, then z, it's just z. So from here we can do sine theta here. That is sine of this one, which is opposite over hypotenuse. Remember that? That is opposite over hypotenuse. I think I should write somewhere like my so ka tua for those that have forgotten. So I have my sine to be opposite to hypotenuse, where this is my opposite and this is my hypotenuse. So I have y over z. I'm going somewhere. This is nowhere I'm heading. So we move to cos now. Our cos theta, which is adjacent over hypotenuse. We have adjacent. If this is my opposite, then this is my adjacent, that is x over z. So and my tangent, that is tan theta, which is opposite over adjacent, that is my opposite against adjacent, that's y over x. If you check this one is positive, all this one too is positive, this one is positive. So everything here is positive. So I can say all is positive in the first quadrant. So your sine is positive, your cosine is positive, your tangent is also a positive value. So let's see what I mean. If I have sine 60, for instance, so all I need to do, be sure it is a positive value. So my sine 60 is 0.8660. 0.8660, that is root 3 over 2. Then if I have like cos 45, for instance, my cos 45 is 0.7017, and this is also positive. So we have tan. My tan 60 is equal to 1.732. So it is also positive. That's why I said they are all positive here. So that is on the first quadrant. Let me go to the second quadrant.